This course will teach you React from the ground up and in great detail. But this course section here will actually not be about React, but instead about just JavaScript. It will allow you to refresh your JavaScript knowledge. And therefore, this course section here is optional. You can therefore skip it, and you can of course also always come back to it if later in the course you see that you need some extra JavaScript help. Because this course section here is recommended if you haven't used JavaScript in a while or if you don't have a lot of JavaScript experience. But I'll also say right away that this section does not replace a JavaScript course. This section is not for you if you have absolutely no JavaScript experience, because if that's the case, you should definitely at least explore some JavaScript basics before continuing with this course. But this section here will revisit crucial JavaScript concepts, and it will especially take a closer look at the core JavaScript concepts you need for building React apps, so for writing React code, you could say. Because in this section here, we will revisit the core JavaScript syntax and rules you should follow when writing JavaScript code. We'll explore the essential modern JavaScript features you should know in general, and we'll of course also especially focus on the features you need to write React code, so the features you will use throughout this course. That's what you'll get out of this section. So let's dive right in, and for that I prepared a code sandbox project, a code sandbox environment, to which you of course find a link attached to this lecture, which gives you a very basic web project with an HTML file and some assets, no JavaScript code yet though. And this is the project we'll use for playing around with JavaScript and for exploring some basic features. I will also say right away that we'll mostly write code that will output content in the console, which in Code Sandbox can be accessed by clicking on console here. Because this section is not about building some super fancy JavaScript-based project. Instead, as mentioned, it is about refreshing your JavaScript knowledge and making sure that you have all the essentials you need for building React apps. So let's start by revisiting certain crucial core concepts and things you should know about JavaScript. For example, that JavaScript can be executed in many different environments. For example, of course, the browser. That's where JavaScript originated. In the end, that's what it was built for back in the 90s. But nowadays, thanks to Node.js and Deno, for example, you can also execute JavaScript code outside of the browser. This will not be the focus of this course, because this is a React course, and React is a client-side, front-end, browser-based library in its core that allows you to build user interfaces with React and JavaScript. But it is of course worth knowing that JavaScript is not limited to the browser. You can even build mobile apps with JavaScript thanks to extra technologies like Capacitor or React Native, which, by the way, would be a great next step after finishing this course. You can also use React in conjunction with another tool or another library, you could say, called React Native to build native mobile apps for Android and iOS. And I do have a dedicated course on React Native if you want to learn more about that after finishing this course. So JavaScript is really versatile, really powerful, but in this refresher section, we're going to focus on JavaScript in the browser, though the general syntax and rules, of course, are always the same, no matter for which environment you are writing your JavaScript code. So since we focus on JavaScript in the browser, let's explore how JavaScript code can be added to a website. And here you have two main options, and they both include the special script tag, the special script element which you can add to your HTML code. You can either put your JavaScript code between such script tags, or you can use those script tags to import JavaScript files, which then contain your JavaScript code. Now, typically we don't use that inline approach on the left here, where the code is between those script tags, because this approach can quickly lead to unmaintainable and complex HTML files, and is therefore typically only used for very short scripts. Instead, typically you have your JavaScript code in dedicated JavaScript files, because such projects that use this approach are way easier to maintain. Therefore, here in this demo project which I prepared, we could start in this assets folder by adding a new subfolder that could be called scripts, though the name of course doesn't matter. And in there we can create a JavaScript code file that could be named app.js, though this name also is totally up to you. It just should end with .js, since that of course tells the browser and also the code editor that this file will contain JavaScript code. And the code editor can therefore, for example, make sure that the code is properly highlighted and formatted. Well, and with such a file added here, you can then import it in the HTML file by going there and adding your script tags, opening and closing script tags. And you always need both. You can't use a self-closing script tag or anything like this. Instead, you need opening and closing script tags. That's a must-have. Now, you can add them anywhere you want in that file, in the head section, in the body section, really anywhere you want. And then you would add the source attribute, the src attribute, to point at the file, in my case in the assets folder, and there in the scripts folder, that should be imported. And now that file would be loaded as part of this web page when the web page is loaded. Now, it is worth noting that you can then add extra attributes to the script tag, for example the defer attribute, to make sure that the script that will be imported will only be executed after the rest of the HTML document has been read and parsed. This ensures that if your script code, for example, needs to work with some HTML elements, those HTML elements are available when the JavaScript code starts executing. Without defer, it would start executing right away, and if you then would try to reach out to this unordered list, for example, this unordered list might not be available yet if the script is loaded before the list is output here. That's why you might want to add defer. Now, in modern JavaScript projects, it's also quite common that you have another attribute on your script tags instead of having defer. And that would be the type attribute, which then is set to module, like this. Now, this type module attribute here on the script tag makes sure that this JavaScript file is treated as a JavaScript module. And if you are treating your JavaScript files as modules, this unlocks one very important new syntax, the import syntax, where you can import code from script A into script B. For example, here we could have a second script file, util.js, which might contain some utility functionality. And in that script file, we could export something with the export keyword and then import it in the app.js file. Now, we'll explore this import-export syntax and this general module feature in greater detail soon. But before we get there, there's one other super important thing you should know about the script tag here in the HTML file. Because before we get there, there is one other super important thing you should know about these script tags and about importing script files in the context of building React apps. Because when you're working on a React project, you will almost never add these script tags to your HTML file on your own. Because React projects almost always use a build process, which, as part of that build process, injects these script tags into the HTML code for you. And in the next lecture, we'll explore why we use such a build process in React projects. Now, if you take a look at a React project, like this React demo I showed you in the first course section, to which you again find a link attached to this lecture, if you take a look at such a project, you'll note that in the index.html file that you find there, you won't find any script tags. There in this index.html file in the head section, I have some meta tags and I have link tags, but I have no script tags there. And in the body, I just have the no script tag that shows a fallback message if the user has disabled JavaScript in their browser, but I got no script tags in there. Absolutely no script tags. And we also never add script tags to that file. Nonetheless, as you can of course tell, if I reload this here, this app works and JavaScript code clearly is executing because the React app is executing. And React, of course, in the end is JavaScript code. A special JavaScript code, but it is JavaScript code. So why is this working? Well, because as mentioned at the end of the last lecture, React projects use a build process, which simply means the code you write is not the code that gets executed, like this at least, in the browser. Instead, the code you write is transformed behind the scenes before it's handed off to the browser. In this demo project on Code Sandbox, but also in the local projects I'll use throughout this course, this is done with help of a tool that's running in the background. And you can actually see that tool in the package.json file. This file simply lists all the dependencies of this project, all the libraries used by that project, and therefore, of course, for example, in there we find the React libraries, the two packages that make up the React library, to be precise. But here in this example, we also find the React scripts library in addition. And this is actually a library that's not going to be executed in the browser or that's used by React once it's running in the browser, but instead this React scripts package here provides a bunch of tools that take your code and transform it behind the scenes before it's then injected into the browser, or to be precise, before it's then injected with help of a script tag into the HTML file here. If you take a look at this running website, for example by opening it in a new window, and you then there inspect this page so that the browser developer tools open up, you will see that now there are some script tags in there, actually multiple script tags. And these script elements were generated and injected into this HTML file automatically behind the scenes by this build process that's running in the background. This preview website, which we see here, is being served by a development server that's also running in the background on Code Sandbox. In a local project, on the other hand, you had to explicitly start that development server. And it's this development server which is watching your source code behind the scenes, and which is then also kind of transforming that source code behind the scenes, and which is then adjusting the HTML file to contain these script elements that do then load that transformed source code, so that the transformed source code is executed on the page. And why do we use such a build process? Why does the code need to be transformed? Well, for two main reasons. The first reason is that raw, unprocessed React code won't execute in the browser. Mostly because React code uses this special JSX feature. Now, you will learn more about writing React code and about JSX later once we start diving into React. JSX code simply is this HTML code written in JavaScript files. Out of the box, this would not work because this is not a standard JavaScript feature. If you would try to use this kind of code in our default JavaScript project here, for example in the app.js file, if you would try to add like a div in there and you would open this website preview and try to reload this page, you would see that you would get an error. An error that in the end points at this div here. because this indeed is not a standard JavaScript feature. It does not work out of the box. So for that reason, to enable this syntax, which is crucial in React apps, as you will learn, because React will be all about including this HTML-like code in your JavaScript files. To enable this feature, the code must be transformed so that you can use it whilst writing the code, but it's transformed to something JavaScript knows before the code gets executed in the browser. That's one reason for using a build process. Another reason is that the code you write would not be optimized for production. It would not be minified, for example. Minification simply means that, for example, names of variables or functions are shortened to reduce the amount of JavaScript code that's served to the user. If you take a look at the code that is served to the user here by, for example, visiting one of these imported code files that is served here in Code Sandbox, you'll see that it looks something like this. Pretty unreadable, not the kind of code we would like to work on as a developer, but valid JavaScript code in the end. Though it is code that's highly optimized to be as short and small as possible to reduce the amount of code that has to be downloaded by the website visitor. So that's another reason why React projects typically require a build process. And the good news are that if you create a React project on Code Sandbox or with help of tools like Create React App or Vite, so if you're using projects as we're using them in this course, those projects all come with such a build process. So you don't have to go through any custom setup or tweak anything on your own. But that's also the reason why you also need to install Node.js on your system in order to work on React projects. Because Node.js is not just used to install packages with the npm command or to create projects with the npx command, as you already learned it, but instead it's also used behind the scenes by these tools that are used by that build process that's running behind the scenes. So Node.js is also needed and used behind the scenes to make sure that your React code gets transformed. So that, of course, was a lot of talking about the build process, but it is important to understand that such a build process is used behind the scenes and why it's being used. Back in our vanilla JavaScript project here, which we'll use for this refresher, we should therefore get rid of this invalid JavaScript code, because this project here indeed does not come with a build process that would convert this JSX code to valid JavaScript code, and therefore here we can't use JSX code, but we also don't need it for this refresher. Now I want to start refreshing your JavaScript knowledge by first exploring this import-export syntax I mentioned before. Because in this course, we're going to import and export a lot of things. Because in React apps, like in most more advanced JavaScript projects, it is considered a best practice to split your code across multiple files to keep it maintainable and manageable. And that's exactly what you do with help of the import and export keywords. Now for that, let's say that in the util.js file, we have a certain value that should be usable in other files as well. For example, in the app.js file. Here we could have an API key variable, and variables in JavaScript are created with the special let keyword, but I'll get back to variables and constants and some key things you should know about them a little bit later in this section. And in there we could store a string created with single or double quotes, doesn't matter. And that string could then contain some cryptic API key that maybe is required in order to send HTTP requests to a backend. This is just a dummy example here, but this overall section will just show you some dummy examples, because in the end it is just about refreshing your JavaScript knowledge. So if that API key, that value here, this string here, should also be available in other files, we need to export it by adding the export keyword in front of it. This makes this thing, this variable here in this case, available outside of this file as well. We can then import it in the file where it should be used, so in this app.js file, for example, by using the import keyword. And then here we need opening and closing curly braces. And between those braces, we then refer to the name of the thing that's exported. So in this case, the name of the variable. If we would be exporting a function, it would be the name of the function instead. But here it's the name of the variable. So API key written like this. And of course, the casing matters because JavaScript is a case-sensitive language. And then thereafter, we need the from keyword to let JavaScript know from which file we're importing this thing named API key. This path to the file then goes between quotes, single or double quotes, again, doesn't matter. And here we then typically have a relative path starting with // if it's in the same folder, starting with // if we want to go up one folder. But here it is in the same folder, so I will use // and then the name of the file with the extension added, at least if you're using just JavaScript. Now, when working in React projects, you will actually see that the extension, the .js, typically is omitted there. That's the case, again, because of that build process that's running behind the scenes, which will add the extension behind the scenes. If you're writing just JavaScript code without such a build process, you do need to add it on your own. But throughout this course, where we do use React projects that come with such a build process that adds the extension for us, we will actually not add it on our own. But here we need to do it. And with that, this API key variable and the value it contains will be available in this app.js file, even though it's defined in another file. And here we could then, for example, console log API key to output it in the console. Now, very important, for these import and export keywords to work, you must be using this type module import here. That's really crucial. Though you will see that for the React projects, if you explore the automatically injected script tags there, you don't find this type module attribute on them. The reason for that simply is that this build process will actually take all your imports and exports and basically merge all these separate files that you have during development into one big file or a bunch of big files, which are then imported with the old school syntax in the right order. This is done to also make this code execute in browsers that don't natively support this import-export syntax, and also so that the browser doesn't have to download dozens of small JavaScript files, but instead just a couple of bigger files, which typically is more efficient. And I'm just letting you know about this here so that you don't wonder why this type module is missing on your React project's script tags. But if you have a vanilla JavaScript app without such a build process, you do need to add this type module attribute here. And with that here in this project, if you save that and reload the app, and you then open this console, you should see your API key being output there. And that's of course coming from the app.js file where we are importing it from the util.js file. Now that's not the only variation of this export-import syntax though. This is one way of exporting and importing things, but in this course you'll also see another way. Besides exporting with help of the export keyword in front of a variable or function, you can also create a so-called default export by adding the default keyword. Now in that case, you must not create a variable thereafter like this, and you also don't assign a name. Instead, you just export the value like this. So now I'm just exporting a value without a name. And when adding the default keyword here, I'm saying that this value here, should be the default thing that's exported by this file. And what's very important is that you must only have one default export per file. If I try to add a second one, I'm getting an error. On the other hand, with the syntax we had before, without default, you can export as many things as you want. Exporting another variable like this wouldn't have been any problem. With the default keyword, you directly export a value and you must only have one default export per file. So I'll also add the old code here, simply so that you see the difference. Like this. And in app.js, the import syntax now also changes if you have a default export. Instead of importing like this, you now import without curly braces. Instead, you just assign any name of your choice. Since the thing that's exported as a default doesn't have a name here, you can use any name you want in the file where you want to import it, but you do need to assign a name. And then you still define the path to the file from which you want to import, like this. With that, if you save this, and again you reload this file, you will see that this again gets logged to the console. Now with help of such a default export and the respective import syntax. And this is also a common way of exporting something and importing something, which is especially useful if you only have one thing, one function, or one value in the file where you want to export it. This is something you will see later in the course once we explore the concept of React components, because there it's quite common that we only have one component, one JavaScript function, as you will learn, per file, and therefore it's quite common to export this one component function as a default, since there are no other things that would be exported in that file. But it is totally up to you which approach you prefer. It's just important to keep in mind that the import syntax also changes if you use the default export syntax here. Now, one last thing you should know about the export and import syntax is that if you have named exports, as this syntax here is called, like this, and let's say you have multiple named exports, for example, you also have another special import syntax you can use. Of course, you can import those named things like this, import API key, for example. I'm just going to comment out this import so that we don't have a name clash. And you could then import all the named things by separating them with a comma here. That's how you would import multiple things from the same file if those things are exported as named exports, so without the default keyword. And as you see here, you can also mix the default keyword with named exports. You just must not have more than one default export. But having a default export in addition to some named exports is absolutely fine. But what you could now do here is that instead of listing all the things you want to import like this as a comma-separated list between the curly braces, you can also import them by grouping them together into a JavaScript object. And that would be done by then using a star, then the as keyword, and then any name of your choice. For example, utils or util, whatever you want. And then again, the path to the file from which you want to import. Like this. With that, all the things provided by util.js would be grouped into this object, and therefore you could use it with the default JavaScript object notation, using its name and then the dot notation to access the thing that was named ABC, or the thing that was named API key, or the default export, which is available under a key named default. So that's how you could then output the API key. And therefore here, if I reload, I again see that API key here in the console. Now, by grouping multiple exported things together into one object. As a last side note, this as keyword can also be used to assign aliases. So for example here, if I go back to this named export import thing, and I'm not happy with the name ABC here, I could assign an alias by using the as keyword after the thing that I want to rename in this file here. And I could rename it to content or whatever I want. And now if I would console log content here, I would be logging the value that is stored in that ABC variable in the util.js file. but I'm renaming it here in the file where I'm importing it with help of that special as keyword, which allows us to assign an alias to the thing that's being imported. So as you can see, there are a couple of things you can do with this import-export concept. In the end, it is pretty straightforward, but you should know about these keywords and how to use them, because we are going to use them a lot throughout this course. So with the import and export keywords and the related concepts, we already explored a bunch of crucial JavaScript concepts and features which we'll use heavily throughout this course. But of course, for this refresher, I now also want to take a step back and also explore some other foundational JavaScript features and concepts, like working with variables, values, functions, objects, and much more. And it definitely makes sense to start with variables, values, and operators. For that, in this app.js file, I'll comment out all this code we wrote before, because we don't need it here. And instead, I now do want to revisit some foundational concepts related to variables, values, and operators. Because in the end, when you're building an app with JavaScript, or with React, which uses JavaScript, of course, it's in the end all about data and therefore in the end values you're working with in your code. If you take a look at applications like Twitter or Google Maps, those apps, like all apps, of course, in the end are about data. The tweets you write and read are data, your location is data, the location you want to go to is data. All these things are data that must be handled in your code. And in your JavaScript code, you can therefore handle a broad variety of values. Most importantly, strings, numbers, booleans, the special null and undefined values, which simply mean that a certain data container, a certain variable, doesn't contain any values yet, and also the special object value, to which I'll get back later. Now, a value in JavaScript can be created in the place where you need it. For example, if I want to output hello world here, I can simply create the string hello world with double or single quotes, doesn't matter, but quotes are of course needed. And if I then save this and reload my app, I would see hello world in the console. So I can create values when I need them. For example, here, when I need a value as an input for this console log command that's built into the browser in the end. But it's also quite common that values should be stored, and for that you're using variables. Variables are simply data containers where you store a value in a variable, which carries any name of your choice, so you assign a name to a variable, and you can then use this variable name as an identifier in your code to refer to that value that's stored in this variable whenever you need to use that value. And you typically use variables because they allow you to reuse a value and because they can help with code readability. Because often it makes sense to not define the value in the place where it's needed, but maybe instead ahead of time so that your overall code stays a bit cleaner and more readable. Now in JavaScript, variables can be created with the let keyword. Here I could create a variable named user_message, though the name is up to you. It just should follow certain rules. For example, it should be written using this camel case notation, where you start with a lowercase character, and if your variable name then consists of multiple words, every word inside of the word, like message here, starts with a capital case character. And it must not contain any dashes or whitespace, so this variable name would be invalid, just as this name would be. Underscores would be allowed, but are not common in JavaScript. Instead, as mentioned, the convention is to use this notation. Variable names also may contain numbers, but not at the beginning. In addition, they also may not contain any special characters like an exclamation mark or a question mark. The only exception is the $sign and the underscore, which I already mentioned. But other than that, the name is up to you. And then I could store this hello world text in user message. If I then want to use this value, for example here for logging it to the console, I would simply use the name of the variable and thereby refer to this value. And that's how I use a variable. And if I now want to log this multiple times, for example, I gain this reusability advantage by using a variable, because instead of having to copy and paste that value, I just define it once and then use that variable as often as I want to use that value. That has the advantage that if that value ever needs to change, I only need to change it in one place instead of multiple places, and all the places in my code where I use that variable will automatically use that changed value. With that, if I reload this, I of course see hello world being output in the console twice. So that's how we create variables. Now, related to variables, we also have constants, which are created with the const keyword. If I save this and reload, I again see hello world being output twice here. So constants work like variables. They are data containers, but the key difference is that constants must not be reassigned. If I try to assign a new value, a new string, for example, like this, I'm getting an error that it's read only because it's a constant. If I were using let here instead of const, everything would work instead. Now I would again see my log here in the console. So that's the key difference. With let, I can use this single equal sign operator to assign a new value. With const, I can't. Now, there are different philosophies out there in the JavaScript world. Certain developers like to use const as often as possible, and I'm one of those developers. Other developers want to use let all the time because it has less characters and therefore requires less code to type. But I prefer to be clear about my intentions, and if I have a value that never should be reassigned, I personally prefer to use const. You can use whatever you want, but you should know about the difference. So let and const are super important. Another very important concept related to values are operators. For example, in JavaScript, we can perform math. We can use the plus, minus, times, and division operator to perform math, and to, for example, divide 10 by 5. And what's important to know about JavaScript is that the plus operator for adding things cannot just be used for numbers, as I'm doing it here. And the difference between numbers and strings is that they don't have quotes around them. But instead, it can also be used with text. For example, hello plus world for concatenating two strings into one longer string. With that code, we would get hello world like this, as one word, because I have no blank anywhere in these strings. But as you can see, the plus operator works absolutely fine here. So you can also use it for concatenating strings. Now, besides plus, minus, times, and division, you also have some other crucial operators. For example, the triple equal sign operator, which is used for checking for equality. And this operator therefore yields a Boolean value. In this case here, false, because 10 isn't equal to 5. If I would be checking 10 equals 10, I instead would be getting true. Now, besides checking for equality, you can also check for things being greater or smaller than other things, or greater or equal, or smaller or equal. And these comparison operators are also very commonly used in JavaScript and will be used a lot in this course, typically in conjunction with the if keyword and if statements, which allows you to execute some code conditionally. For example, here I'm comparing 10 to 10, which is kind of redundant, of course. Typically, you would instead compare some dynamic user input, but for this demo here, I'm using two hard-coded values. And if this condition is met, which in this case here will of course always be the case, the code in the if statement will execute. But I'll get back to if statements a little bit later again. Here, if I reload this, I therefore get works, because of course this condition here is always met. Again, this is a redundant condition. In this course, in the apps we're going to build with React, you will see conditions that make more sense. Now, besides variables and constants, another crucial JavaScript concept are functions, which can either be created with help of the function keyword or with help of this arrow function syntax, to which I'll get back in a couple of seconds. Let's start with the function keyword. The idea behind functions, no matter how you're creating them, simply is that you're defining some code that's not executed immediately, but instead at some point in the future when you call the function, and that can be executed as often as you want because a function can be called multiple times. Now, to show you what I mean, let me finish this function. And this is how you write a basic function. You give it a name, which comes after the function keyword. Then you have a so-called parameter list, to which I'll get back in a second. You do create it with the opening and closing parentheses, and you need these parentheses here. And then you have opening and closing curly braces, and between those curly braces, you put your function code. So the code that's not executed right now, but at some point in the future. So for example here, I could put a console log statement into this greet function, and if I would save this and reload this page, you would see nothing in the console. The reason for that is that this function is defined but never executed. Because as mentioned, with a function you're defining code that's not executed immediately, but at some point in the future when you call the function, when you invoke the function. And you do that by using the name of the function like this, and then adding another pair of parentheses after that name, but without the function keyword in front of it. With the function keyword in front of it, you're defining it. Like this, you're calling it. And now when this code is encountered in your code file, the code in the function will be executed. So now with this added, if I save this and if I reload this page, now I do see hello here, because now we're calling the function. And as mentioned, I can call the function as often as I want. You can literally add as many function invocations here as needed. And if you save that, you'll therefore see hello being output 5 times. Because I have 5 function invocations here. That's how you define and call a function. And this is a super important concept which we'll use all the time throughout this course. Also, especially in React, it turns out that we'll define a crucial React building block as a function. But you'll learn more about this later once we dive into React. Now, functions cannot just be defined and executed like this. Instead, they also take so-called parameters, input values. For example, username and message. You can add as many parameters as you want, you simply separate them with a comma. These parameters are then available inside of the function, and only there. So here I could then output username, with a capital N, and then thereafter also message. I can do this because I'm accepting these 2 parameters. And since it's your function, these parameter names are up to you, but they have to follow the same rules as these variable names did. The same, by the way, is also true for the function name. This should also be defined just as you learned it for the variable names. For example, if it's a word that consists of multiple words, you would also use this camel case notation here. So now this function takes 2 input parameters, therefore when you're calling this function, you also should provide values for these input parameters. Because in the end, the idea behind using parameters simply is that you can have one reusable function that can be reused with different input values. For example here, I could call it with max and hello the first time, and then call it again where I greet Manuel and say hello. What's up? Like this. Now I'm using the same function with different input values. That's possible thanks to parameters. And therefore, if I reload this, I see Max and hello. And then I see Manuel and hello, what's up? Now, what's also worth noting here is that you can also assign default values to parameters by adding an equal sign here. For example, hello. This would allow me to call this function without providing a value for the second parameter, and if I don't provide one, the default value will be used. But I can, of course, also overwrite that default value by simply providing a value for that parameter here. With that, if we reload this, I get max and hello, thanks to this default here. And then I get manual and hello what's up, where I do use this value for overriding the default. Now, functions can not just take input values, but they can also return values by using the return keyword. So for example, in this function, instead of console logging username and message, I could return a string that combines both. I could return a string here where I say, hi, I am, a white space here, and then I add the username, and then another white space or dot maybe, and then the message. So now with that, I'm using this function here to in the end construct a string based on these input values. And we could also use return if we would not accept any parameters. In this case, I'm using the parameters for deriving the returned value, but if you have a function that doesn't need any input in order to work correctly, you of course also don't have to accept one. Parameters and the return keyword work totally independent from each other, but as in this example, they can also work together. So with that, this function here no longer greets a user, but instead creates a greeting. And therefore, we also might want to rename it. Because whenever you name things, functions, variables, whatever, you should describe what's stored inside of it in case of a variable or constant, or what it does in case of a function. So here, since it no longer greets a user, but instead creates a greeting string, we might want to rename it to create greeting. And then when we call it down there, we of course also no longer get any output in the console. Instead, now we should store the result in a constant or variable, because this function now returns a value which we can use. We could use it as an input for console log, for example. And therefore, in that case, we would see, hi, I'm Max, hello. Maybe we should add a white space after the dot here to improve the formatting. But since this here is not great from a readability perspective, we instead might want to store it in a constant or variable like this, and then use that constant or variable so that the overall code is more structured. So with that here, we could get our two greetings, and then of course also console log these two greetings. And therefore we would see those greetings again. So functions can also be used for producing and returning values. And they should be named such that it's very clear what a function does. Though in the end, of course, just as with the variable names, the function names are up to you. Now what you see here is one way of defining a function. But I'm going to comment out this approach here for the moment, because there also is an alternative. In JavaScript, you can also create so-called arrow functions, a syntax that's especially popular if you're dealing with anonymous functions, functions that don't need a name. For example, here in this React app I showed you in the first course section, you might remember that on the buttons we had this onClick attribute, and we used some React syntax to point at a function that should be executed when the button is clicked. And for that here, I used this arrow function syntax to define a function in the place where it's needed as a value for this click listener. And this is a so-called anonymous function because it doesn't carry any name. It's just the function code. Now, anonymous functions can also be defined with the function keyword. You can define functions like this, and for example, console log hello. And we could then, for example, export this as a default if we wanted to, and we would now be exporting a so-called anonymous function which doesn't carry any name. But if you are dealing with such anonymous functions, you can use the arrow function syntax as well, since this is a bit shorter. When using arrow functions, you omit the function keyword, you must not use it, and you instead just have your parameter list here, like for example username and message. This doesn't change. Then you have this arrow, and then you have the curly braces, which contain the function body. You can also still use the return keyword here if you want to. And that's how you would define a function using this arrow function syntax. In this course, you'll see both kinds of functions, using the function keyword and using this arrow function notation. Ultimately, it is up to you which approach you prefer, but you should know about both. So now that we learned about functions, I want to come back to values. And specifically, I want to come back to objects. As you should already know, objects in JavaScript can be used to group multiple values together. So for example, if I have a user name, which could be Max, which typically of course would not be hard-coded, but might be fetched from a server or from some HTML input on the page. And I have a user age, let's say, of 34. I could group these values together in an object. So that instead of defining them like this, I could have a user object, which is created like this by using opening and closing curly braces on the right side of this equal sign here, like this. And then there I could have a name property, as it's called, and an age property. So I have key value pairs where the keys are up to you, but should follow the naming rules you already learned about. They also should of course be descriptive. And then separated by a colon, I have the value that should be stored under that key. Now this object could be used to output it in the console, for example. If I refresh this page here, I would see my user. And in this JavaScript console, I can actually also explore it. But I can also access individual fields of that user object here, or of any object, by using the dot notation. And then, for example, I can just access and output, in this case, the name field. So therefore now, if I reload this to get rid of the error, I would see Max. And this dot here is the key to accessing values in an object. You use this dot notation to get access to a value in an object. Now, besides key value pairs like this, objects can also store functions, which we then typically call methods. For example, here I could create a greet function like this without the function keyword, just the name of the function you want to have, followed by the parentheses, which could accept parameters if you wanted to, and then your curly braces, and here you can return something, or for example, simply console log something. And then you could access this again with the dot notation and execute it like any other function by adding these parentheses here. With that, if I reload this, I would see hello here. Now, if you are in such a method, so in a function that belongs to an object, you can also access the properties of this object, so the other methods and fields that belong to this object, with help of the special this keyword. This would, for example, allow me to output the age here by using this, which refers to this object, dot age. And with that, if I reload this, I would output the age here. The this keyword won't be too important for this course, because we won't create too many methods here, but nonetheless, it is a JavaScript concept you should know. Now, when it comes to creating objects, you can either create them like this to group values together, or you can create blueprints by using the special class keyword. This is also an approach we won't use too much in this course, but I briefly want to mention it here. With the class keyword, you can create a blueprint that can then later be used to create the actual objects. Here we could create a blueprint called user, like this. And what's important here is that for class names, you should start with a capital case character. And then here you could, for example, add your methods that should be part of that blueprint. Like this. In addition, you can add a so-called constructor function by using the special constructor keyword, which other than that is written like a normal function though. And you can use this constructor for accepting parameters, input values like name and age, for example, and then store them in properties of the object that will be created based on the class with help of the this keyword again. So that's how I would create properties named name and age, and store the parameter values name and age in these properties. Now by doing that alone, we won't achieve anything yet. Instead, we can now use such a class blueprint by instantiating it with help of the special new keyword, which creates a new object based on that blueprint. And then here I could pass manual and 35 as values. And if I now console log user1 here, I would be getting an object, this object here, that is based on this blueprint. So this object here is based on this blueprint. And therefore it contains the values I passed as input parameters to this constructor here. That's how these things work together. In addition, this user1 object would now also have a greet method because I defined the greet method here. So that's where this hi is coming from. Again, we won't use this class keyword a lot in this course, but you should know about it. But with that, that's it for objects. I'm going to comment out this code here. And we can continue with the refresher for the next concept. Now, besides objects, another crucial JavaScript value type are arrays. Though technically arrays are objects, but they are special kinds of objects. Now, an array is created by using square brackets, opening and closing square brackets. And the idea behind an array simply is that you can create a list of values. So where objects allow you to group values together with key value pairs, the idea behind arrays is to have just values which are stored in a certain order and which can be accessed by their position in that list. So for example here, if I have an array of hobbies, let's say sports, cooking, and reading, if I have such an array, I can access the array values by using square brackets after the name of the variable or constant that stores my array. So by using these square brackets here. And then there I use the index, as it's called, of the element I want to output in this case. Now the index starts at 0. So sports here has an index of 0, cooking has an index of 1, reading has an index of 2. If I want to output sports here, I would therefore access hobbies, square brackets, 0. With that, if we reload this and take a look at the console, I would see sports. Now arrays are a super common value type in JavaScript because it turns out that you quite often need to store a list of values. For example, in this demo React application I showed you earlier in the course, there also was a content array which actually contained more arrays as values, because that's also important to know. Arrays can contain any kinds of values. They can contain other arrays, objects, numbers, strings, whatever you want. Here I have an array of more arrays, and those inner nested arrays then actually contain strings. Now, when defining an array, the individual values that make up the array are separated by commas, and then, as mentioned, you access values by their index. Now, since arrays are such a super important, very common value type in JavaScript, there actually also are a couple of built-in utility methods you can use on arrays to transform or read the values stored in the arrays. You can access these utility array methods by using the array name and then the dot notation, And then you should automatically get a suggestion of the methods that are available here. For example, there is the push method, which allows you to add a new item to an array, for example, working. If I add this here and I then console log hobbies, you will see that now hobbies here actually contains 4 elements, therefore ending with the index 3, since we start at the index 0. And the last element is this working string I just pushed onto the array. Now there of course are way more methods, and I'm not going to explain them all here, but for example another method which you should know, which can be quite useful sometimes, is the findIndex method. This is a method that allows you to find the index of a certain value. For this, findIndex actually takes a function as an input, and that's a great use case for using such an arrow function, since it's super short to write and not a lot of characters to type. This arrow function, which you pass to findIndex, should accept at least one input parameter, which could be called item, because findIndex behind the scenes will execute this function, which you're passing to findIndex, and will automatically provide a value for this input parameter. Therefore, of course, your function also must accept it in order to then use it in this function body. Now in this function body, in case of findIndex, you then should return true if you have the item that you were looking for, and false otherwise. For that we can return item equals sports, for example, if we were looking for the index of the item sports. So if we were looking for the index of this item. What this code here does is it executes this function automatically behind the scenes for every item in this array, including this working item, which was pushed onto the array. And then for every item, it compares that item, so that text here, to this text with help of this comparison operator, which I mentioned before. If the two are equal, this function here returns true, and therefore findIndex knows that I found the item I was looking for, and it will then give me the index of that item. Otherwise, this will return false, and findIndex will do nothing. So therefore here, I could store that index in a constant, and then console log it. If I save that here, I get 0, because indeed sports, which is the item I'm looking for here, has the index 0, since it's the first item in that array. Now this code can definitely be a bit more challenging to understand, since we're passing a function to another function, and that's also something I'll get back to a little bit later in this section again. But in the end, all that's happening here is that findIndex needs a function which it can execute on our behalf, and it will execute this function for every item in this array. It will pass that item for every execution into that function, and therefore, of course, item will be different for every execution. It will be those items here. And then we compare the item we're getting to some value we're looking for. So this value we're looking for, of course, is defined by us, the developer. That's how this function here works. Now, as a side note, if you have code like this, an arrow function where all you do in the function body, so between these curly braces, is return something, you can even shorten this code and get rid of the return statement and get rid of these curly braces and write this code like this. Also get rid of this semicolon here. This is then the shortest possible way of writing this, and another advantage of using such an arrow function, because this is now a very short, concise piece of code for defining a function that takes an input called item and then compares that input to some other value to yield true if these are equal or false otherwise. Now, another very useful utility method you'll see a lot throughout this course is the map method. Map allows you to transform every item in an array to another item. For that, map, just like findIndex, takes a function as an input, typically such an arrow function, since this is such a short and concise way of writing this. And like this arrow function for findIndex, this arrow function here also will receive every item in the array as an input, because this function also will be executed automatically by map for every item in the array, and every item of the array will then be provided as an input value to this function when it's being executed. And then here you return the value this item should be transformed to. For example, item plus exclamation mark. So that I add an exclamation mark to every string here. This, of course, is just a dummy example, but when working with React, you'll use this map method a lot for outputting list content, for mapping data into such JSX elements. But that is something I'll get back to later again. Here I'm just mapping my items to strings with an exclamation mark at the end. And what map will do is it will not edit the original array. Instead, that array will stay unchanged. And instead, map will return a new array, which I'll name edited hobbies. If I then console log edited hobbies here, and I reload this page, I therefore get my edited hobbies here, with all these exclamation marks at the end. So that's what map does, and since we'll see map quite a bit throughout this course, I definitely wanted to mention it here. Now what's important to note about map is that you can really use it to transform any item to any other kind of item. For example, here we don't have to convert our strings to new strings. Instead, I could also convert them to JavaScript objects. For that, I would create an object with opening and closing curly braces, which here, however, would have to be wrapped with parentheses, since otherwise they would be treated as the parentheses that wrap the function body. If I instead want to return a JavaScript object, I have to wrap the curly braces with parentheses, and this will tell JavaScript that these curly braces will not define the function body of this arrow function, but instead will define a new object returned by that arrow function. And then here, I could define any key of my choice and, for example, store the item, which in this case will be such a string, as a value for that key. Really, you can create any kinds of values here. Any objects of any shape, numbers, strings, booleans, whatever you want. Here, in this example, I'll in the end create a new array that's full of JavaScript objects where every object has a text key, which value is the value from the old array. So if we save this code and reload this, I now have a bunch of objects in my array, and if I expand those, you see that I have this text key here, and the value then is the value I had before in my array. And that's of course the case for all these objects. Now, related to arrays and objects, there are two crucial, relatively new and modern JavaScript features you should know because you will also see them quite a bit throughout the course. And the first feature is about destructuring arrays and objects. For that, let's take a look at this array. An array that contains some username data, the first name and the last name. Of course, it could be stored in an object, but here it's an array. Now let's say in our code we want to work with both the first and the last name. Now what we could do to make that a bit easier is we could create a new constant or variable called first name, where we extract the first element of this array, which is the first name, by using index 0. And then we could add a last name, where we also use username data, and we use index 1 to extract the last name. This could be done, and from now on we could use first name and last name, which is a bit more meaningful than always working with username data 0 and username data 1. But this code can be shortened. Instead of using this code here, we could create these two constants or variables in one single step by adding square brackets here on the left side of this equal sign. On the right side, they will create a new array. On the left side, they will destructure that array, which simply means that this syntax can be used to pull values out of this array. And now you can define new constants or variables with any name of your choice here. And the first constant or variable here will be mapped to the first array element, the second one to the second element, and so on. And this is a super useful syntax, since this, of course, is way shorter to write than what we had before. And from now on, I can also console log first name and console log last name and use these constants like this, even though the original data is in an array. But due to restructuring, we can pull out these values and store them in separate constants or variables. So if I reload this page here, I see Max and Schwarzmuller here in the console, because of these two constants that are created with help of this destructuring syntax. Now this destructuring syntax also exists for objects. We cannot just use it for arrays. For that, let's say we had a user object that looks like this. Now again, we might want to store these values in separate constants or variables. For that, of course, we could create a name constant and store user.name inside of it, and a age constant and store user.age inside of it. That would work. But again, this can be shortened here. Instead of writing this code, we can again use destructuring, in this case, since we're dealing with an object, by writing curly braces on the left side of the equal sign. On the right side, they will be used to create an object. On the left side, they are used for destructuring, just as we used square brackets on the left side for destructuring an array before. Now we're using curly braces to destructure an object. And then here we can pull out name and age, though these names here are now not up to us. Instead, we have to use the field names that are defined in the object. For array destructuring, these names were up to you because the elements were pulled out by position. For the object, they are pulled out by name, so by property name, and therefore you have to use the same property names here. Though you could assign an alias by using a colon here and then defining your alias name on the right side of that colon. When creating an object, so when using the curly braces on the right side of the equal sign, the colon is used to separate the key of a value, the property name you could say, from the value that's stored under that property. When using curly braces on the left side of this equal sign, so when using them for destructuring, the colon is instead used for separating the property that's pulled out of this object from the alias name that should be assigned to it. And with that here, we could output username and age. And we would be using these destructured values for that. So therefore, again, if we reload this, we would see these values here. And this destructuring syntax really is a crucial JavaScript feature, which we'll use a lot throughout this course, and therefore now you know about it. Now, the other crucial concept that's related to arrays and objects about which you should know is the special spread operator that exists in JavaScript. For that, let's for example say that we want to merge this hobbies list with another hobbies list. In this case, for example, another list that only contains one item. If I would want to create a merged list, I could do that by creating a new list with the square brackets. And then I could use the special spread operator, which looks like this. 3 dots. Yes, it looks weird, but this is JavaScript syntax using 3 dots. And then the name of the first array you want to merge into this new array. For example, hobbies. These 3 dots will pull out all the elements of this array, so sports and cooking in this case, and add them as separate, comma-separated values to this new list. If I would just add hobbies like this and new hobbies like this, I would get a new array which, when output to the console, will actually look like this. Now it's an array with 2 nested arrays inside. This might sometimes be what you want, but often it's not. If I instead use the 3 dots in front of the arrays to use this spread operator, I will pull out the values from these arrays and add them as standalone values to this array. And with that, if I reload, this new array I get now does not contain nested arrays, but instead the values from the merged arrays. And that's what the spread operator does. It pulls out values from an array and adds them as separate, comma-separated values to a new array here. And we will indeed use this spread operator from time to time in this course, and therefore you should also know about this. You can also not just use this spread operator on arrays, but also on objects. For example, if I have my extended user object here, where I also have the isAdmin flag, let's say, a property named isAdmin, which stores a Boolean value, and I now want to merge in the properties from the other user. Now for that, I can again use the spread operator, because it's also available in objects, and spread my user with help of these 3 dots into this extended user. Here, the spread operator will pull out all the key value pairs from this object and add them as key value pairs to that object here. Therefore, if I console log this extended user now, I'll get a new user which has this isAdmin key, but which also has these key value pairs from this user here. All thanks to this spread operator, to the 3 dots. So enough for hobbies and objects for now. Let's explore control structures. I already mentioned the if keyword, which is used to create so-called if statements before. The idea here is that you compare values, for example, and you then execute the code inside of the if statement only if this condition here is met. Now, the if statement also allows you to add an else statement to define the code that should be executed if this condition is not met, and also else if statements if you want to check for more conditions if the first condition wasn't met. And you can add as many else if statements here as you want, but only one else branch. Now, of course, checking for hard-coded values like this makes absolutely no sense. This will always be true, for example. Instead, typically, of course, you'll use if statements to check content you don't know in advance. For example, here, I could get some dummy password by using the built-in prompt function. This is a function provided by the browser which will prompt the user for input. You see here, I get this overlay that opens up. Here I could type your password, and now I would get this overlay which asks me for a password. Now here I'm getting this overlay whenever I type a couple of characters in my code here, and since this is a bit annoying, I'll indeed go to the preferences here, and then the Code Sandbox settings, and set the preview settings to disable preview on edit, so that it will not automatically re-execute the code after I typed a couple of characters. So with that, I'm now fetching this password, and I could now check if the password is equal, using the triple equal sign operator, to hello, let's say, written like this. And if that's the case, I'll console log hello works. Else, if this condition here should not be met, if the password entered by the user is not hello written like this, I could check if the password is maybe equal to hello starting with a lowercase l, in which case here I could console log hello works. But else, if that's also not the case, I might want to execute this fallback code here, where I say access not granted. With this now, if I save this, the code does get executed again, but I'll still cancel this and manually refresh to clear the console. And now if I enter hello with a capital L and press OK, in my console I'll see hello works, because since I entered hello written like this condition here was met and this code here was executed. On the other hand, this code and this code was not executed. That's why the if statement is called a control structure, because it controls which code gets executed. If I reload this and I enter anything else, like this here, and I press OK, I get access not granted because, of course, I did neither enter hello written like this nor written like this. Therefore, this code got executed. So that's the if statement. Another crucial control structure you should know about is the for loop. Now, JavaScript knows different types of for loops. One very important kind of for loop we'll also see in this course is the for loop where we loop through an array. For that, I'll again create my hobbies dummy array here with sports and cooking, let's say. And now if I want to execute some code for every entry in this array, I could create a for loop where I create a constant that will be recreated for every iteration of that for loop, because for loops are about executing the same piece of code multiple times, as you will see. And I could name this constant hobby, because now with the special of keyword, I tell JavaScript that it should create a new constant for every item in this array, and it should execute the code between these curly braces as often as needed to go through all these elements in this array. So for this array, 2 times. So if I then console log hobby here, for example, this code, this console log code, will get executed twice because I have 2 elements in this array. The first time for hobby being equal to sports, the second time for hobby being equal to cooking. If I save this and I reload here, enter anything here and open the console, I see sports and cooking being output here because of this line of code being executed multiple times. So this for off loop is also a kind of loop you should be aware of, because we'll also see this in this course. Now, something we'll not see a lot in this course is that we'll reach out to the DOM and select elements in the DOM manually in JavaScript code to then read or change them. Now, being able to reach out to the loaded website and read and manipulate it at runtime is, of course, a strength of JavaScript, but it is also something we won't do when using React, because React will do it for us, because we write React code in that declarative way, as you learned in the first course section. So selecting elements, for example, with query selector, to then remove them from the screen, for example, like this, is not something we'll do a lot or at all in this course. Instead, we'll use React for that. And with that, we're almost done for this section, but there are a couple of essential features that we'll use in this course and a couple of tricky features, which I also want to refresh here so that you know about these JavaScript concepts and features and you don't wonder about them when you encounter them later in the course. The first JavaScript feature you should be aware of is that you can pass functions as values to other functions. For example, we could set a timer with help of the built-in setTimeout function, a function that is provided by the browser. Now, setTimeout wants 2 input values. It accepts 2 parameters. The first input value it wants is a function itself, though. A function that can be defined with the function keyword or as an arrow function. Now, what's really important to understand here is that what we're doing here is we're creating a new function. An anonymous function here, since it has no name, but nonetheless a function. And we could absolutely create that function manually in a separate step. It could be named handle timeout or anything like this. And here we could console log timed out. So this would now be a regular function. And we could also alternatively define it as an arrow function. Could be named handle timeout2. And we store an arrow function in that constant because arrow functions never accept a name in front of them. They always are created in an anonymous way, but we can make them non-anonymous by then storing them in a constant or a variable that has a certain name. And then here I could console log timed out again, anything like this. So here I'm creating a function with the function keyword or as an arrow function stored in a constant. And we can now also pass this function or this constant that contains a function as a value to set timeout. So as a value for this first parameter that wants a function, instead of defining the function right here in place, which would be an alternative though. Now what's really important to understand here when you're passing a function to another function though, is that when you're not defining it here in place, but instead you defined it in advance, you pass it by just using its name. So you don't add parentheses here, you omit those parentheses. Because by just using the name here, you're passing the function as a value to this function. If you would add parentheses here, you would instead make sure that this function, handle timeout here, gets executed immediately at the point of time when this timer is set, in this case here, and therefore it would be the return value of that function, if it would return any value, which this one does not, that would be passed as a value for this first argument, this first parameter, to set timeout. And that of course would be the wrong thing to do here, because here I don't want to pass the return value of that function to set timeout, but instead the function itself. So that internally set timeout can execute this function at some point in the future. And that's why you must omit the parentheses here, so that you don't execute this function right away, and you instead pass the function as a value to set timeout. Well, and then here, set timeout takes a second argument as well, which is now not a function, but instead a number, which defines the number of milliseconds JavaScript should wait until it executes this function, which you passed as a first argument to set timeout. And I can of course also do that with handle timeout too. Now just to be clear, you can always create an anonymous function instead of defining a function in advance. And then you could of course also add any code you want to execute to that. But when you define such an anonymous function, you're also not executing it yet. Instead, you're also just defining it, and you're passing that defined function to set timeout. So you're in the end doing the same as you're doing here by defining it in advance and passing a handler to that function, the name of the function, to set timeout. You're essentially doing the same here when defining the function in the place where it's needed. You're still only defining it. You're not executing it immediately. Well, and therefore here, if you save that and you reload, you'll see nothing initially, but then once these timers expire, you will see the different messages they output. Now, knowing that you can pass functions as values to other functions is an important first step, but you should not think that this is only possible for built-in functions like setTimeout. Instead, you can also build your own function, like greeter, for example, which accepts a greet function parameter, so a regular parameter in the end, but a parameter which expects to get a function as a value. And then inside of greeter, we could execute greet function like this, so calling it as a function by adding these parentheses. And now we could call greeter like this and pass a function to greeter. Like for example here, an arrow function where I console log hi. If I do that and save everything and reload this page and open this console, you will see hi here. And this hi is of course coming from this console log message. So this function here is getting executed because we're passing it as a value for this greetFN parameter to the greeter function, and inside of that greeter function, I'm then executing this greetFN parameter, so the value that's received on that parameter, which is this function. So this function down here is passed as a value to greetFN, and then greetFN is executed here. Therefore, indirectly, this function is getting executed there, because this function down there at the bottom is the value received here on greetFN. And I just wanted to mention this here because it really is important to be aware of the fact that passing functions as values is not limited to built-in functions like setTimeout, but can be done with all functions, including your own functions. Those can also accept functions as input. Now, another thing related to functions, which you'll see quite a bit in this course, is that you can define functions inside of functions. Now, when writing vanilla JavaScript code, this often might not make too much sense. But it will make more sense in the context of React, as you will see later. Nonetheless, you can define a function, for example called init, which then contains another function defined inside of it. For example, a function named greet, which console logs something. Then, inside of init, you can execute greet, but you can't execute greet outside of init, because greet is now defined inside of init, and therefore it's scoped to this init function, which means it's only available in there, just as a variable you would define in here would only be available inside of init and not outside of it. And therefore, inside of init, you can execute it, but outside of init, you can't. Here, though, we can execute init because init is scoped to the overall file, since init is not nested into another function. And therefore, with this code here, if you reload this, you will see that we do output high, so that this code here does get executed, because in the end we're executing this function, which then internally calls greet, which is this function here that was defined inside of init. So you are able to define and execute functions inside of other functions. And again, whilst this is not something you might be doing too often in just JavaScript, it is something you'll do a lot, as you will see throughout this course, when writing React code. Now, the last crucial concept I want to cover here is related to reference versus primitive values. So what do I mean by that? Well, if we got a string, like user message here, that's a primitive value. Strings, numbers, booleans are all primitives. What's special about primitives in JavaScript is that we can't edit them. I can, of course, overwrite user message and store hello there, but that's a brand new string. The old string, which was stored in memory, will simply be thrown away. It's not edited to be this string. Even if I execute a method on user message, because just like arrays, strings do come with methods you can call on them, and I, for example, concat another string by using the concat method, this will produce a new string instead of editing the old string. So when dealing with strings and numbers and booleans, you always produce new values. You can't edit existing values. This changes when you're dealing with objects and arrays, which technically, as mentioned before, are objects. If I have a hobbies array here, with sports and cooking, let's say, and I then use, for example, the push method, which is a built-in method, to also add working to that array, I edited the original array. If I console log hobbies here, I get this new array, which contains working as a third item. Because push indeed edited the original array, it mutated the original array. Because arrays are objects, and objects in JavaScript are so-called reference values. Which in the end, to simplify it a bit, simply means that in a variable you don't store the value, but instead the address of that value in memory. So that array is stored somewhere in memory, so in the memory of your computer, and it's the address of that place in memory that's stored in this constant. When you then call push, for example, JavaScript will reach out to that address, open the value in that address, so take a look at that array in this case, and add this new item to this existing array in memory. So the array in memory changes, the address does not. With primitive values, like this string here, you could instead say that the string itself is stored in the variable. This is technically not 100% correct, but you can think of it like this. So you don't have this address thing here. This instead only matters when you're dealing with objects. There it's this address that's being stored. And that's also the reason why I can edit this array despite using const here. Const means that the value can't be edited, right? And still I can do it here. Well, because const technically does not mean that the value can't be edited, but that the variable can't be overwritten. So when using const, I can't use the equal sign operator to assign a new value. That won't work. If I save this, I'm getting an error. But I can absolutely store objects in a constant and then take advantage of the fact that those objects are accessed by reference, by address, to manipulate those values in memory by using that address. And I'm just mentioning this here because it can sometimes be confusing that I can edit an array, for example with push, despite that array being stored in a constant. Well, as I just explained, I can do that because I'm storing the address in this constant, and the address doesn't change, so I'm not violating this idea of having a constant variable which is not overwritten, but I'm instead editing the value that is behind that address, and that in turn absolutely is allowed.